Good afternoon. Thanks for coming to this talk. My name is Yong Tang. I'm a maintainer of CoreDNS project. In today's talk, my focus is mostly about the introduction to CoreDNS. I'm also going to discuss about service discovery with hybrid and multi-cloud. Okay. This is my profile and GitHub handle. By the way, in case you have any issues related to CoreDNS, you can always ping me on GitHub. I should be available most of the time, I hope. In today's talk, we are going to go through several sections. First of all, I'm going to give a brief introduction on CoreDNS in case the audiences in this room are still not familiar with CoreDNS. I'm also going to give a status update since last KubeCon, just to talk about what has happened, what new feature has been added. Also, I'm going to briefly mention about our participation in Google Summer of Code and the Community Bridge sponsored by Linux Foundation. The next section is about technical deep dive. During the technical deep dive, I'm going to discuss about the plugin systems with CoreDNS, how to do service discovery with hybrid and multi-cloud. And finally, I'm going to give a brief demo with some simple setup to see how to wire up your CoreDNS with AWS and Google Cloud. Okay. First, some introduction about CoreDNS. As you may figure out, CoreDNS, first and foremost, is a DNS server. It is a very flexible DNS server written in Go. And the biggest difference between CoreDNS and other DNS server like Bind is that CoreDNS is focusing on service discovery. It's not a truly DNS, a standard conformant DNS server like Bind, but it has a very unique plugin-based system, which means if you want to have any features or you want to have any functionalities, you can always enable different plugins to achieve that. And in addition to that, because it has a unique plugin-based system, you actually could assemble different functionalities into your own CoreDNS binary. And in case there's some functionality that's not available in main CoreDNS code, you can actually write a plugin very easily as long as you know how to write in Go. In the past KubeCon talks, I normally give a demo about how to write a simple CoreDNS plugin. But in this case, since this is the intro, I'm going to skip this part. But if you look into CoreDNS code base, you're going to realize it's really straightforward. Everything has been laid out easily, such that you only need to just find the DNS record for input and find a way to pass the process the DNS packet to the next layer to achieve any functionality you like. Some of the features supported by CoreDNS include DNS over TLS, and DNS over gRPC. By the way, the DNS over gRPC is not a standard. It's actually a customized implementation. Perhaps the biggest advantage or biggest usage of CoreDNS is its integration with Kubernetes. We all know since Kubernetes 1.11, CoreDNS has been bundled as part of Kubernetes release. And since Kubernetes 1.13, it's a default DNS server. So whether you notice that or not, CoreDNS is actually serving DNS in Kubernetes clusters as long as your version is higher than 1.13. Another thing I want to discuss about is the cloud vendor integration of CoreDNS. This is actually one of the focus of this talk as well, because I'm going to, at the end of the talk, I'm going to show a demo about how to use CoreDNS to sync up your DNS record saved in raw registry. Sync up DNS record you saved in Google Cloud DNS or Microsoft Azure DNS. This actually also introduced the usage of hybrid and multi-cloud deployment for service discovery. Finally, CoreDNS started by Mick Gibbon, and he's still the leader for this project. Some brief update about the CoreDNS community. At the moment, we have almost 200 contributors, and it's growing. We have 14 maintainers. We have 30 public adopters. By the way, we have the adopters are publicly available, which means only those companies or organizations are willing to share their name with us. We're going to put that into our adoptions list. Another thing I want to mention is that we reached 5,000 stars just, I think it's just a couple of weeks ago. And one more number I want to share is that we have 46 million Docker Hub downloads. I think this is absolutely amazing because several years ago, when CoreDNS was introduced and was introduced into CNCF, it was considered to be the smallest project. And it's just amazing. After several years, CoreDNS reached a graduate level in CNCF, even ahead of several other projects. So I think this is absolutely amazing, and it's a great achievement for CoreDNS and the CoreDNS community. Talking about the CoreDNS community, there are several places that's very active. GitHub, obviously, is the biggest one. Maintainers are very active on GitHub, and you should be able to get most of the help from GitHub. The Slack channel is also very helpful. We have some other resources like the website, the blog, and the Twitter. If anyone ever watched the GitHub update, you probably noticed that there are a lot of discussion happening every day. So it's a very active project. Since in the past several months, we participate in several programs. One program is the Google Summer Code. CoreDNS started participation in Google Summer Code since 2017, and we participated in the last 3 years. And the achievement has been absolutely amazing. From the Google Summer Code, we have some interesting implementations such as DNS tab. We also have implementations of access control list. Like for this year, the implementation for Google Summer Code is access control list, which actually give you the ability to block any unwanted DNS queries if the source IP of the DNS query is from an unwanted user. So this is a very useful feature. Just considering that if you have a CoreDNS setup and you deploy the server and you have a publicly reachable IP, you certainly don't want to have the whole internet to flood the DNS traffic to you. So with ACL, access control list, you actually can block those unwanted DNS queries and make your web server a lot safer, DNS server a lot safer. Another program we participated for the past summer is a community bridge program sponsored by Linux Foundation. This is actually kind of interesting because initially during this year's Google Summer Code, we received lots of proposal submits. There are a lot of students want to participate in Google Summer Code. Eventually, we select one. Then CNCF decided they probably can sponsor another one, but that's unfortunately they only have one slot open for Google Summer Code. So with the help of CNCF and the Linux Foundation, another proposal was accepted as a community bridge program sponsored by Linux Foundation. In this program, it's more interesting. The implementation for community bridge actually implemented the Google Cloud DNS, which is one of the most important features, and that's one of the features I'm going to show in this in the demo of this session. Again, that's good news for CoreDNS. And also next year, we plan to participate in Google Summer Code as well. So if anyone is interested or you know any student want to participate in this program, you certainly would encourage them to apply, and we hope we can continue this trend. Okay, we talk about CoreDNS is a plugin-based system. So how exactly plugin works? The plugin in CoreDNS essentially it's chained together. You can select any plugin. If you enable a plugin, the plugin will be traversed through one by one. And if at any layer, if the DNS query has been processed by a plugin, the DNS query response will return. If the plugin decided to say, okay, I don't know how to process this DNS query because I have no idea, then you can decide to let the plugin to pass through. Next plugin will pick up the DNS query and do the processing, return the DNS query. So the idea is really simple. So we have different format of plugins. You can, if you have interest, you want to contribute to a CoreDNS plugin, you have different ways of contributing. One way is that you say, okay, I implement a CoreDNS plugin. I want to be part of the community. You can certainly add that, add the plugin to link that from CoreDNS website. There's no real restriction or limitations about linkage. As long as the CoreDNS related, we are happy to link the plugin. If you say, I want the plugin to be part of the CoreDNS org, we can also accept that. The only requirement is that it need to be sponsored by at least one maintainer. The reason is that if a plugin is incorporated into CoreDNS org, CoreDNS community and maintainers share the responsibility to maintain this plugin. So we do require one maintainer to sponsor the inclusion of a plugin. And finally, if you say, I just want the plugin to be enabled by default, so anyone downloading a binary from CoreDNS website or downloading a Docker image for CoreDNS, they can use my plugin directly. It actually have a higher standard. We want to see a good quality. We want to see a wide usage, and also we want to see someone is willing to help maintain. So that's actually the requirement a little bit higher. In the past, like a couple months or so, there are quite some interest to include additional plugins. The discussion has been going on, but generally we want to see certain levels of interest from the community, not just one or two individuals. If you say, okay, my plugin, I have a plugin, I shared it with someone else, and we see a lot of usage. If you want to say, okay, I just want to bring this plugin to core repo, then you can certainly do that. We can participate in discussion and see how to move forward. Okay, and so far we are talking about the community update and the introduction. The next thing I want to talk about is the service discovery. Actually, for the past several years, whenever I talk about the DNS, a lot of people actually ask, there's one interesting question a lot of people ask, say, okay, why do you need DNS? The reason people ask the question is that in this day and age, we reach a level of SDN. SDN is all over the place. With software-defined networks, you essentially can have virtual IPs assigned to any device and route anywhere you want. So people say, okay, yeah, it looks like SDN can solve all the issues. What exactly is DNS used for? Why don't we just say, okay, everyone has IP instead of domain name, so any advantage of using DNS? So from that standpoint of view, I think there are several reasons. So first of all, DNS is really an indirection. And people talking about indirection think it's a bad thing, but it's not necessarily a bad thing because you do want certain level of flexibility for indirection. For example, you have a web server. It's deployed on AWS. Now you never know what's going to happen next year, right? It's hard to say because in Silicon Valley, everything moved very fast, but in the world, it's equally fast as well. Now let's say several months later, you are now certified with AWS. You say, okay, I want to move to another cloud vendor. I want to move to Google Cloud. What are you going to do? You certainly can do a big migration. You can ask a customer to say, okay, you are going to update some IP address to do that because there are some infrastructure restrictions because of the limitation of IP. But if you say you have a DNS as a front end, and the DNS is a front end, hide your IP behind, you actually can smoothly transition your customer from one cloud to another, or from cloud to on-prem, and you have a lot of flexibility to reach your goal without interrupting your customer experience. So I think that's the biggest advantage of having DNS as a front end, even in this day and age where SDN is all over the place. There's another reason for DNS is that DNS is really simple and easy. If you want to change a record in DNS, how easy it could be with CoreDNS, literally it could be just one line of change. But if you want to change your IP from one to another, depending on which VPC or which CIDR block you're in, it might be a challenge. Another thing is that DNS is very pervasive in IT infrastructures, which means if you want to integrate your DNS setup with your corporate IP, with your enterprise, with legacy infrastructure and the most advanced infrastructure, you can always find out that everyone is using DNS one way or another. It's very pervasive, so it's a good thing to adopt the DNS so that it's going to help you for any deployment. And finally, DNS is distributed in nature. It may not be the most sophisticated distributed system, but it scales really well because it scales to the internet. The whole internet essentially is DNS-based, so that actually helps. Like I said, we talk about scalability. We wanted to have essentially DNS can give you the ability to scale without any limit. Okay, the next section I'm going to talk about is to introduce about CoreDNS Corefile configurations. As if anyone ever played with CoreDNS, you probably noticed that CoreDNS actually use a configuration called Corefile. The format of Corefile actually is kind of interesting because it's actually inherited from open source web server called Caddy. If anyone interested in Golang, probably heard of Caddy HTTP server. Initially, CoreDNS was really a fork of Caddy. So a DNS server, that's a fork of HTTP. It's kind of interesting. When Mick started the project, he essentially forks Caddy and convert that into a DNS server, and we adopt the same format of configuration file. That's in Caddy, that's Caddy file. In CoreDNS, we call it Corefile. If you look into this configuration file, you'll probably notice there are a lot of things in place. First of all, it's part of Kubernetes system, so you can actually do service discovery for your Kubernetes clusters. The second plugin we enable is Route 53, which means if you have a backend of AWS services, you can actually reach them directly. The third section is a host plugin, which gives you the ability to add a record by a line to expose the endpoint. This is interesting because host file was supposed to be only serving a limited range of DNS entries, but in the past, we actually saw some of the interesting users, like one user use a very big core file to serve I think 80,000 DNS record. It looks like it's still working, so it looks like it's no big issues. The next plugin is a health check. Health check gives you the indication of if your DNS server is healthy or not. Of course, talking about the health check, you also want to have certain level of monitoring, which is the next plugin of Prometheus. With Prometheus, you can collect metrics. You can wire up with your monitoring system and show in your UI. The next one is the cache, which is Of course, you want to do cache in DNS because you don't want your DNS server to talk to the backend every second, right? Next is the forward plugin. The forward plugin essentially gives you any unresolved domain to a next DNS server so that you can chain up. This is how DNS works over the internet. In this setup, Corefile setup, we configure CoreDNS to talk to Cloudflare's public DNS so that if there's any unresolved DNS entries, it's going to talk to a public DNS server to resolve that. And finally, errors, that's just for logging and error handling. Okay, now let's see what exactly the CoreDNS is doing with this Corefile. As we can see, the Corefile is here. If you switch to a diagram, it's actually a mixture of different endpoints. We have a Kubernetes cluster, we have Route 53, we have some host file that's going to give you arbitrary and potentially total random DNS entries. We also have Cloudflare for DNS resolving. One thing I want to mention is that if you look into the communication, there is a difference between Route 53 and Cloudflare. The difference is that if your CoreDNS has been configured to talk to Route 53, it's actually not talking to Route 53 through UDP. As we all know, the DNS packet is actually UDP packet. Why you don't want to use UDP when you traverse the internet to talk to AWS is that, first of all, UDP may not be very reliable. It's actually lousy transportation. In case of cloud vendor sync up like Route 53, you actually could use AWS API endpoint to get the information. So that's how Route 53 was implemented. It's also how Cloud DNS and Microsoft Azure DNS was implemented in CoreDNS. We essentially talk to API endpoint through ATPS, which is much more secure and much more reliable. When the data was fetched from the cloud vendors on CoreDNS, we interpret those data and present as a DNS front end. So no transportation between CoreDNS and cloud vendors through UDP. They're through HTTPS, which is much more secure. Okay. Next I'm going to talk about hybrid and multi-cloud. As we mentioned that CoreDNS is able to talk to different cloud vendors. So that's actually bringing the interesting question of how do you sync up data in different clusters. So one interesting is you actually can set up CoreDNS so that they can talk to each other. Your CoreDNS could expose the front end locally so that your local cluster can always talk to a CoreDNS deployment. And your local deployed CoreDNS server can be configured to talk to different backends. They can talk to Route 53 for any DNS entries in AWS. They can talk to Cloud DNS, which actually in Google Cloud. And also, if you're more creative, you can even configure the CoreDNS to talk to API server of Kubernetes clusters from outside of a cluster, which actually means you have one cluster in one cloud. As long as your API server in another cloud is exposed and reachable, you actually can wire them together so that any IP or any services in any cluster can be synced up on every cluster. So that's the interesting usage of hybrid and multi-cloud. We talk about, by the way, why DNS is still useful. We mentioned it's very important to have indirection. DNS as an indirection, it's actually the service discovery. When you talk about service discovery, it's about DNS host name mapped to an IP address. But you want this service discovery because you want flexibility. You also want to have different kind of configuration so your service can be exposed in a way you want. Or you also want to have certain level of policy control such that your endpoint are only exposed to those endpoints that's necessary to reach that. Okay, so we are quite close to the end of talk, but I'm going to give us a demo about a simple demo about how to use CoreDNS. So first of all, so what exactly I'm trying to demo? The demo is very simple. I'm going to wire up CoreDNS with 3 plugins. The first plugin is RAW53, which is the AWS DNS record. The second plugin is Google Cloud DNS, which, as you could see, it's actually going to expose any endpoint in Google Cloud. And the third plugin is Who Am I? This is not a true plugin. It's more like an identity to expose the CoreDNS server itself. So if you could see, by the way, we mentioned in the past about the CoreDNS is a plugin-based system, which means whenever there's a DNS query, it's going to go through one plugin after another plugin and until the DNS query has been picked up by one plugin and processed and returned. So in this case, if AWS RAW53 plugin decided to pick up demo on AWS record, as you could see on the first entry, then it's going to return. The second record, we create that record on Google Cloud. That means AWS will not be able to know anything about this record in this zone. So it's going to pass through to next plugin, which is Google Cloud. Google Cloud will reply with the correct IP address. And finally, if you have another entry that's not in AWS or Google Cloud, it's going to pick up from there's a typo. It should be Who Am I? Okay. So the next entry is the Corefile. I mentioned about the CoreDNS itself. It's really simple and straightforward. That's the configuration. So how many lines in this profile? That's exactly like less than 10 lines, right? And just to think about how much it could do with such simple configuration. As you can see, the first entry is the RAW53 plugin. All you need to do is to map a zone to RAW53's zone ID. The second plugin is CloudDNS, which is Google Cloud DNS. You map a zone to a managed zone ID, and that's it. You also need to provide a credential. I'm going to explain a little bit why this is the case, but that's pretty straightforward. And finally, you have a Who Am I plugin, which actually is identity to give you an indication of which server this is. Okay, let me just give a simple. Okay, I hope everything works fine this time. This is very simple. So this is nothing special about configuration. CoreDNS itself is compiled as a static binary, which means you can download from CoreDNS GitHub website and download binary and run directly. I'm going to show you the Corefile. So as you can see, it's a straightforward Corefile with several entries. There's nothing special about that. I placed my first project. This is a what? Oh, sorry. Let me. Oh, yes, definitely. Thanks for reminding me. Yes, I want to show. Let me see. Oops. Oh. Is that good enough? Okay, great. As you can see in this directory, there are only several files. Actually, we can remove the tar file. You have CoreDNS binary, which is essentially just binary. That's the one you download from CoreDNS Github repo. The second file, that's a Corefile. As I explained, I just copy paste from the slides. Only like several lines. The last one is it's actually my Google Cloud credential. I'm not going to show the content of this credential, but you can see here I don't need the AWS credential. That's because AWS by default will check your home directory if you have if a home directory has something like that. The credential is saved in this file, and AWS will pick up this file automatically. Of course, you have different ways of saving the credential or different ways of policy. For example, if you're running your instance on AWS, you could attach an instance profile to your policy of the instance, and then you even don't need all those credentials passing around, which is a good thing. For Google Cloud, you still need a JSON file. So let's just show how to start. That's all you need to know to see how to get started. Now let's open another window to show. I'm going to, okay. So let's just do a dig. Say, if you look into that, I'm trying to ping a domain name, ping a record that has been created on AWS, and it gives us 1234, which is exactly the address. Now, if you say I want to ping the one on GCP, it also gives us a file. If you notice, name server actually has changed because this one is controlled by Google Cloud, so that's a different IP address. Of course, if you say, finally, that's who am I plugin, which is a fallback plugin. That's almost the end of the demo, but I want to show you one more thing. Okay, I think everyone knows AWS is nothing, it's pretty straightforward. But in Google Cloud, there's one interesting, if you notice this record of your zone. You see the warning. This zone isn't visible to any network. What does that mean? That actually means I just created a record. I didn't attach this record to any VPC or any network. And it's still able to, your DNS, your CoreDNS is still able to get to AWS, get to Google Cloud, fetch this record, and expose and present to you. That actually means, if you like, you can use the Google Cloud DNS as a backend database to save on your DNS record. And you don't need to expose this DNS, you don't need to expose this database to anyone. And CoreDNS will be able, as long as the CoreDNS is able to reach to Google Cloud API, it's able to fetch the data and expose that to you. And you can deploy this CoreDNS in any VPC you like. You can deploy that in AWS. You can deploy that in your local cluster as an on-prem deploy, or you can deploy that in Microsoft Azure if you like. And then once the once the record is there, you can decide how to wire up the network so that only those containers that actually need to access those services will reach there. So that's one interesting I realized when I play with Google Cloud DNS. That's a nice feature, I believe, because that's actually give you ability to use Google Cloud as a backend for DNS database. We are almost to the end of the talk, but I'm going to I'm going to just finally I'm going to discuss about how to help CoreDNS, and if you have any ideas, you have any interesting implementations. There are several ways to help CoreDNS. First of all, you can start on GitHub. I mean, this day and age, number of stars probably is one of the most important things for open source project. If your institution or your company is willing to share the name with us, you can certainly add a name to adopt.md in GitHub repo. And we are glad to accept any publicity, any exposure. You can also participate in GitHub or Slack channel discussions. And finally, you can create the PRs to, if you find any bugs to want to fix, or you want to contribute to any interesting plugins you feel like it's important to the community. The last but not the least is how to become a maintainer. Our standard of become a maintainer is actually pretty low, as long as you can contribute to a significant pull request. And talk about significant pull request means if you just fix typo, that's probably not going to count. But if you can add additional functionality, and if the pull request has been accepted, if you can find one maintainer to sponsor you, then we'll add you to maintainer list. It's like a nice badge because CoreDNS is a CNCF project. So with just one pull request, you are already a CNCF maintainer. And this is a badge that's probably going to help you and help you reach a wider community. I think that's pretty much it for today's talk. Just wondering, any question you want to ask? Yes.
You showed an example where CoreDNS servers in multiple clusters were talking to each other.
Yeah.
What plugin is that?
Actually, it's already, you can doing that. The default way of deploying CoreDNS is that for each cluster, you can deploy a CoreDNS. For each cluster, you deploy one CoreDNS. And the CoreDNS by itself is pretty much stateless, which means they are going to talk to different backend to fetch the data. In case of like Google Cloud, it's actually going to talk to Google Cloud API. In case of Kubernetes, it's going to talk to Kubernetes API server. And the API server itself can be exposed to even to outside of the cluster, which means even if you are in another cluster, you can still, your CoreDNS can still talk to another cluster API server and fetch information. Like I said, at the end of the day, CoreDNS is a stateless server, so there's no data stored by CoreDNS itself. So you certainly can freely deploy CoreDNS in any clusters. In fact, in one of the production environment I work for, the company I work for, a common setup is that we actually deploy CoreDNS on each node. It's actually give you the scalability and give you maximum flexibility to do all kinds of things. Yeah. Okay.
One question
here. Yeah.
Does the Route 53 integration work with the AWS special service location zones or just regular Route 53 zones?
It actually works with anything as long as entries are accessible. Like I said, it's actually going through the AWS API, which means it's controlled by the IAM policy tied to those zones. So as long as the zone is accessible by the credential, then you can reach that. Yeah.
I have a question here.
Yeah.
What can you do with a plugin? What capabilities do plugins have? And the second question about plugins is how do you actually load them to the runtime?
The plugin actually, like I mentioned in one slide, the plugin is essentially a binary, and in runtime, you'll just decide to enable or disable the plugin. By default, if you check one of the slides.
We're just about out of time, but I'll have a deep dive tomorrow, and I'll go into how to break plugins. But plugins are all compiled in they're not dynamically loaded.
Okay. Yeah.
Excuse me, what upcoming features are on the roadmap or can we expect pretty soon for DNS, CoreDNS?
That's a great question. If you asked me like several months ago, I was planning on adding Cloud DNS and Azure DNS into CoreDNS, and fortunately, we have excellent contributor from Community Bridge program and from different contributors. They add those features. If you talk about what kind of features we are going to add, I think that's going to be interesting discussion. But if you have any interest, feel free to open an issue so we can continue the discussion on GitHub. Yeah.
Yeah, you may also want to come to the deep dive. I'll talk about some of the external plugins that you wouldn't see unless they do some interesting things.
Okay, I think that's it. Okay, thanks everyone for joining this talk. Have a wonderful day.